So in this lab, we are going to get familiar some vector data analysis, and also I think the most important part is that how can you use those analysis to try to answer some questions. Um, so here you can see we have the ArcGIS Pro is open. So let's first create our map and download the data that we need for this lab. So let's create a template, open the map template, and let's call it lab 7. And again, we are going to save our data into our OneDrive folder. And we are going to create a new folder that in OneDrive for lab 7. Okay, so lab 7. Okay, so now the project is being created. So let's first go to catalog and let's download the data that we need. So let's go to catalog portal and let's download the population data that are maintained at the Living Atlas. So where the Esri maintain those data. So let's search population state. And specifically, we are looking for this one, ACS population variables. So let's drag this one to our projects. And it contains 3 layers. So the population at the state level, population at the county level, and also population at the census tract level. So we just need the first one. And also if you right click the attribute table of this one, you will know that actually each layer contains a lot of columns. So we just need population for each state and also for each county. So what we are going to do next is that we are going to export the data to our local geodatabase. So we'll repeat that what we did in the lecture. And here you can see import data and also the database. So let's call this one state population, and let's keep the state GNIS code, geocode, postal code, name. We don't need the area of the land. We don't need the area of the water. And this is the total population, so we can keep that. And everything beneath total population, so we can use Shift key and we can remove. Okay, so make sure that we just keep 1, 2, 3, 4, 5, those 5 columns, especially we have the name of the state and also population. And let's run this export. Okay, so we have the state population being exported. So if we check the attribute table, and so we have exactly what we want: population, state name, and also the other code that we may need in the future. And let's do the same thing for the county. So let's see, data, export, and this one, let's call it county population. And let's just keep the county's code, and we don't need area of the land, area of the water. Let's keep the county name and also state name and also total population. So everything that beneath total population will be removed. Okay, so make sure we just keep 1, 2, 3, 4, 5 columns, especially the county name, the state name, and also total population of that county. And let's run it. Okay, so now we have the county that is ready. And again, if you check the population attribute table, and you can see we have the population, state name, county name, etc. Okay, great. So now we can safely remove the downloaded the feature from the Living Atlas. Okay, and if we go to our catalog and project catalog, and you can see that in the geodatabase, so you can see the county population and also state population are now being saved. Okay, next let's go to the all portal. So this is where you can search the data that are shared by other ArcGIS users. So let's search mass shooting 2019. So that is the data that I uploaded. So remember that from the previous lab that we geocoded the mass shooting from the GONE archive. And here you can see this is I am the owner of this feature layer. And let's add this one to the current map. So here you can see that we can also see the charts that I created from the previous lab and also this proportional map. Let's also export this one to our local geodatabase. Okay, so let's right click and export features. So here we can call it mass shooting 2019. And we can keep all the fields, that's fine. And in the environment, okay, because we geocoded those data, so this data does not have a PCS, it only has GCS. So here there's also an opportunity that we can define the PCS for those geocoded points. So we can choose that, okay, we are going to use the same PCS as the state population or the county population. And let's run it. Okay, so now we see that mass shooting has been exported to our geodatabase. So now we can safely remove the one from the all portal. So now we have our data ready. So we have the mass shooting. In the 2019, we have the population at the county level, and also we have the population at the state level. So our first question focuses on the mass shooting at the state level. So here we can see that those are the events of the mass shootings. So for each single mass shooting, we know that where they are located and also how many people being killed or injured in each incident. Okay, so that's the data we have. So now the question is asking that, okay, so at the state level, so how many mass shootings are there for each single state? And also what is the total number of people being killed or injured for each single state? Okay, so the question is that how many number of the mass shooting incidents in each single state, and also what's the total number of people being killed or injured. For example, in this case, West Virginia has 0 incidents. That's great. And also you can see Virginia, there are several. Okay, so there are two spatial analysis can help answer that question. The first one is one that we mentioned during the lecture. So if you remember that, we go to the analysis, and you can just open the toolbox and also find out a spatial drawing, so that can help answer the question directly. Or if you know that in this tool window that spatial drawing actually is one that has been frequently used, so we can also call it from here. Okay, so let's click spatial drawing, and in this case the target will be the state, and the drawing feature will be the mass shooting. Okay, and the output. Okay, so output we should be very careful about output, because if we give inappropriate output, so we can easily forgot what we are doing. So spatial and drawing mass shooting, and we keep 1 to 1. And here we can see we keep the population and the length, area, name, etc. For the incident date, we don't need that information. For the state, we don't need that information. For county, we don't need that, and also address, we don't need that. For people being killed, yes, we want to keep that one, and also for the aggregation or for the merge rules, we want the total. So that means for each single state, they will sum up the number of people being killed, and also similar for the number of people being injured. So we also want the total. And the match operation optional, here we can choose intersect, which is perfect. And now let's run it. Okay, so now you can see the result is here. So if we uncheck all the others, just look at the spatial join, and if we right click the table, and we'll see that we have 52 states, and we can see that for different state, the join account is how many points are located within each state. And we actually can sort this one. Let's say descending order. California has the most number of the instance, and followed by Illinois. And if we go to the right, and we can also see the total people being killed and also total people being injured. So we can also easily sort those values. Okay, so Texas is a state that has most people being killed, and if we sort by injured, so California is also a state that has the most people that have been injured. So now we have the data, we can further visualize or explore the data. So for example, we can create a map to show the number of the instances in each single state just based on this spatial join feature. So let's say we make sure this one is selected, and we go to the appearance, and we can create a graduated color. Okay, we choose graduated colors. Here we use the join account, which equals the number of people, a number of instances. That's fine. And you can choose the classification method. So as we mentioned, you can use natural break, quantile, equal intervals, standard deviations, etc. And also number of classes, so no more than 5 as a general rules. And also you can choose a color that you like. Okay, so here we can see a clear pattern that which state has more gun violence incidents. You can also perform some non-spatial visualization. So for example, here I can create a chart, or I can create a scatter plot matrix, where I'm interested in seeing that how the population is related. So let's say I want to see that the population relate to the number of instances and also number of people being killed and also injured. So I hit apply. Okay, so now I have this scatter plot, and I can also show the R square. Okay, and you can see which one has the highest R square. So the number injured is highly related to the instance, which is because if you have more instances, definitely there will be more people that will be injured. And also population versus number of people being killed. So R square is 0.70. Okay, so that means if you have more, the state has more population, so it's highly likely that there will be more people being killed. Okay, so that is a scatter plot matrix. So that's one way that we can get those results. So if you go to the tools analysis, and also if you open this tool window, you can see that ArcGIS Pro also has some other tools like summarize within, summarize nearby, and also statistics. So if you are not familiar with spatial join, I feel like summarize within might be more intuitive. So let's try that one to answer the same question. So the question is that for each single state, how many people being injured and also killed in total. So let's say summarize within. And again, input polygon will be the population for each state. And also summarize feature, we are going to summarize the mass shooting in 2019. Okay, and output. So here again, pay attention to the result. So let's say we want to use the population summarize mass shooting. Okay, and in the field, so here we can say, okay, for the killed, we want the total, and also for the injured, we also want the total. Okay, you can also add additional group field, but here it is not necessary. So you can see that summarize within is kind of more intuitive. So if you're not familiar with the spatial drawing, so you can also choose summarize within. And now let's run it. Okay, it finally finished. So if you check that every time when you are running some tools, there's details. So if you check the details, and there's a pop-up window that contains all the information that you run, so the input data, output data, all the parameters. And you can see that when I run summarize within, it took 7 minutes. Okay, so that's pretty slow. So is far way slower than a spatial drawing analysis. Okay, so let's look at the result. So if we open the attribute table, and actually pretty much the same thing. So count of points, some people being killed, and also some people that injured. So let's make sure that both layers, so from the summer within and also spatial drawing, both layers are selected. And let's go to map, and let's say we want to query the visible part, see if we have the same result. Okay, so let's see, check the taxes. And for taxes, we can see we can simply maximize the window, and we can see for the first result 71 31 73 146. For the second one 31 73 and also 146. So that's pretty much that's exactly the same. So that means to answer the same questions, there are several ways that you can do that. You can use either spatial drawing, so that will give you the result, or you can use the new tool that called summarize within. So choose the one that you like and also that you feel more comfortable. Okay, so let's remove those results, and let's also remove the state population. So let's just leave the county population and also the mass shootings. Okay, our second question is that, so we're going to look at the county levels. And so for each single instance, so we want to say that what is the population that within this within a buffer, so within a buffer that with radius of 50 kilometers. Okay, so within a buffer of 50 kilometers, so how many what is the population within that 50 kilometers for each single buffer? Or within 50 meters, what is the population? So to do that, again, there are also several ways. So the first way, that probably the most straightforward, is that we're going to run a set of analysis. So for example, we are going to first create a buffer. That is this one. And we choose mass shooting. And this one we call it mass shooting buffer. And let's say we want the 50 kilometers. And next, let's say, okay, so that is the 50 kilometers. And we don't want dissolve because we want each instance has its own buffer. Okay, and now let's run it. Okay, so now we can see that for each single zone, each single instance, we have its own buffer. Okay, so next we want to calculate the population. So within each buffer. So what is, let's say, average population within each buffer? So the county layer has a population. So the next we can do an intersect. So we go to analysis and let's do an intersect. So the input feature will be the buffer and also the population. Okay, and the output, so let's say that the output will be the buffer intersect population, and we want to keep all the attributes, and we run it. Okay, so it is finally completed. It took 15 minutes, and I don't know why it is so long. Normally, so if I use a local ArcGIS Pro, and I think it will just 1 or 2 minutes. So probably, I guess, because everything is run on Amazon AppStream, so that it's slower, so that you can see 15 minutes. So that's pretty amazing. Okay, so look, if we look at the intersect part, and we can see that for all the part that so the overlapped when the buffer overlap with the population, so we have a unique part. Okay, so if each buffer covers different counties, so that will be a unique counties. And if we open that attribute of this intersect, okay, and we'll see that, okay, so for each individual buffers, what are the population for each single county? Okay, so for each individual buffers, what is the population? Okay, so what is the population for each county? Okay, for example, if we look at the first one, okay, so that is this part. We can see that the population of that county is less than 200. Okay, however, in that instance, we have 4 people being killed. And if we move on to the next one, to another one, we can see for this part, the population is this, and also it's a same buffer, I guess, actually. Yes, same buffer. So this county that has 200 population. Okay, so now we know that for each county that each buffer covers multiple counties, and different counties have different number of populations. So now we want to know the average population for each buffer, so that is within 50 kilometers of each instance. So to do that, we can also go to the analysis, and here now we can use this summarize statistics. So let's click that, and here the input table will be the intercept, so the buffer intercept the population, and output table, so so they just give us an automatic output table. So let's mass routine intersect. Let's just call it mass routine intersect summarize. Mass routine intersect POP summarize. Okay, and for the field, so now let's say we can get the population. Okay, county population, and we want the average. Okay, and we can also include the people being killed, and we can get the average. So that will be the same actually, and also people being injured. Let's say the average. So here the case field. So based on which case field, so we want the FID of the buffers. Okay, we want the FID of the buffers. Okay, so basically we want to see, okay, so for each buffer, what is the average population? So here, for example, for this buffer, we have 1, 2, 3, three different counties. So we want to calculate average of the population. The average people being killed and the average people being injured will be the same for each buffer because the value will be the same. Okay, so now let's run it. Okay, so let's look at the detail. So it took about 2 minutes, so that's okay. Now let's look at the table. Okay, so now we can see for different instances, so we can see the average population and also for that instant, the number of people being killed and also being injured. Okay, so here we have this result. Of course, we can create visualizations. So for example, if we want to create a chart, we can create a new chart and scatter plot matrix. And here we can see that the population and also people being killed and also injured. Okay, so you want to see that if there is a strong correlation that within 50 kilometers, if you look at R square, we can see R square is almost 0. And if we look at the line, the trend line, linear trend line, you can see that it's off. So there's no strong correlation between number of people being killed or injured versus the local population, so the population within 50 kilometers. Okay, and also if you want to create a map, you can link this one back together to the mass shootings, and you can also create a map that shows the population within 30 kilometers. Okay, so that is one way to do that. So we need 3 steps: intersect, buffer, intersect, and also summarize. And if you want to create visualizations, you also need to join the table back to the feature classes. So it's feel like, okay, so there are a lot of work to do to just get this simple result. So is there a simple way to do that? And the answer is yes. Okay, so let's clear the result first. So let's say we remove the buffers, intersect ones, and also the tables. So here let's go back to our question that, okay, so now we have the mass shooting and also population at the county level. So the question now become, is there a simple way that we can calculate the average population within 50 meters for each incident? The answer is yes. So it is called search nearby. Okay, so search nearby is also more intuitive. So if you are not familiar with spatial analysis, however, so it is very convenient, but it is not free. Okay, so it is not free. So let's try that. So let's say the input feature. Let's say, okay, we still want mass shooting, and the summary will be the county population. Okay, so here we see the mass shooting summarized nearby. So let's put that one to be more specific. So summarize nearby population. And here you can choose, okay, so how do you want to measure the distance? Is that driving distance, driving time, walking distance, etc. So let's just use a straight line. And the distance will be 50 kilometers. And what are the statistics do you want to use? So I want to know the average population. Okay, so just one single step. Okay, one single step, and also it's very easy to understand. However, it is not free. So it is not free. So don't abuse this analysis. That's right. Well, this is really a marathon analysis, so it took like 40 minutes to finish. To be honest, if I run on a local computer, so normally it will take 2 to 3 minutes. So I'm not sure, is that a problem of ArcGIS Pro or is that a problem of the AppStream? For AppStream, we are also using a decent instance. So okay, so let's look at the result. So as you can see that ArcGIS Pro also the summarize nearby also create a bunch of buffers. And if we look at the attribute table, and you can see that yeah, they create those 50-meter buffers where we do have number of people being killed, injured, and also the average population. So that is the last column. So if you want to, you can also create visualizations, either a scatter plot matrix or create a map. So let's see, that's something that's slightly different than the way that we did. Okay, and basically you can see it's much similar. So the R square are zeros. Okay, so I think the results are consistent to the one that we have done earlier. Okay, so that is second way that how we can calculate the average population within 50 kilometers of each instance. Okay, my last scenario is that, okay, so suppose what if I don't even have the population, so I just have the mass shootings that in each locations in the past year. So but I still want to get the number of the average population within 50 kilometers. So is that possible to do that without population being downloaded? And the answer is yes. So if I go to this tool window, I can see there's also a new tool called Enrich. I really like this function because so that basically you just need to bring the data that you are interested, and you can always enrich your data. So you don't need to go to the census website to download those data. So you can just click the enrich and they can do everything for you. And also, of course, you can see that this will also cost credits. So let's say try it. So let's say I want to enrich this one. And how do you want to name your output? So that's enrich. That's fine. And let's add variables. And now you can see it's great. So here you have the variables in different categories like health, housing, spending, race, education, crime, policies, etc. And we are looking for the population. So let's click population. And so we're looking for the population totals. So here you can see there are also more specified population data. And let's just look at 2020 total population. Okay, so yeah, so that's also another advantage because when we download data from census, we can only download from 2019, but here you can see 2020 is also available. Okay, so that's pretty cool. And here again, you can define your distance, how to measure the distance. Do you want straight line, driving, etc.? So let's just straight line. Distance or times we want, in this case, 50 kilometers. Okay, again, so this is probably the best tool that I like on ArcGIS Pro, and however, it is not free. So use it with cautious, especially if you have so many records. So be careful about this one. And let's run it and see how long it will take. Okay, to my surprise, it only took 1 minute. Okay, so that's awesome, and that is kind of normal duration of those kind of analysis tools. And here we can see we have new points being created. So if we open the attribute table, And we can have a sense that they also still created a buffer. Okay, so they created 50 kilometer buffer, and next I'm not sure what kind of calculation they use, but they did calculate the population for 2020. And one thing that notice that they are using the population at the block level. So if you remember that for census data, we have data at a state level, county level, tract level, and also block level. So block level is the finest level that have the population data, have the census data. So that is also awesome. And if we want create a scatter plot to see that how that look like, so see if that has some change if we use the enriched data. Looks like well, the R square is still almost zero, so there's no significant information that relationship between a number of people killed or injured to their local population, so the population within 50 kilometers. Okay, and finally, so if we go to the analysis, and we can see that there's a history. So if we click history, and we can see all the analysis we have done in this lab. Okay, so whenever if we save the project, so those history will also be saved. And so if you double click any of those history, so for example, if I double click buffer, so it will count out the analysis that we had done yet. So for example, if you want to repeat the same process to a different dataset, and you can easily do that by checking out the history.